Woohoo! And welcome to part 2 of multiplying and dividing radicals. Yay! I've brought along Square Bear, who's going to help us calculating and simplifying all of these radicals. And I have great news as we come into this part. We're going to multiply and simplify, which is great and super fun. I know you all were looking forward to that. But also, all variables will represent non-negative values. Pardon me, Square Bear. So that means no absolute values. There we go. Yay! So, no absolute values, it means that whenever we encounter variables, we can assume that there's not going to be any sneaky negative stuff that we have to worry about. So, it's going to make things a lot more streamlined and simple. And to make it even more simple, to begin with, we're just going to go ahead and work with square roots or radicals and numbers, constants. Okay, so let's go ahead and review. I've got the square root of 18 or radical 18 times the square root of 2 or radical 2. Now, right now in our class, we only have square roots. But I will tell you that as you move on through math, we start to throw in other sorts of roots, like cube roots and fourth roots. So the first thing we need to do is whenever we're multiplying and trying to simplify, let's double check these are both square roots. Now, how would we know these are both square roots? It's the same symbol. Now, if it were a cube root or a fourth root, you'd see a slightly different symbol. So just double check these are both square roots, or just we call them radicals. Then you can go ahead and combine them. Isn't that awesome? This is like one of the best rules about math. Okay, I'm going to go ahead and multiply 18 times 2 and get to 36. Now, why would I do this? Normally in math, we usually like to stay with simpler numbers. So why would I go to a bigger number? Well, here's the thing. I don't actually know off the top of my head what the square root of 18 is. I know it's 4 point something, but it's not nice. It's not an even whole number. And the same thing with the square root of 2 or radical 2. However, for the square root of 36 or the principal square root of 36 or radical 36, I know what that is. That's 6. So in this case, sometimes combining the two radicals together and then simplifying, we can actually come up with the exact answer in a much easier way than if we had tried to deal with these two separately. So that's all. Let's try radical 21 times radical 18, or the square root of 21 times the square root of 18. So the question is, what do we do with this? Well, if I take a look at this, radical 21 isn't a perfect square. So this is going to be messy. Same thing with radical 18. Now in this case, if I multiply them together, okay, so let's see, 21 times 18, oops, sorry. Get out of the light, Carol Ann. There we go. 378. Now I'm going to tell you that 378 is not a perfect square. I just know this because of practice. You could always check on my calculator. Taking the square root of a number you already have on the screen is a little bit tricksy, but let me show you how you do it. What you would do is you would say, okay, I got this number on the screen. Either you remember it, 378, which is one thing, or I'm going to go into my square root, which is on this calculator, I have to touch second and then the square key to get that square root. Now you see it erased what I had before. So I could just remember 378 and type it in, or on this calculator down here, see where it says ans? That's the previous answer. So I'm going to go second answer. See that? It tells me take the square root of the previous answer, and that is a mess. Now, that is an approximation for the square root of 378, and that's fine. But in this section, we're looking for exact values. So, okay, let's go in Let's invite Square Bear back. Rawr. And let's go ahead and see what we see. So remember what happens. What we're going to do is I'm going to simplify things by bringing everyone into one cabin. So I got 21 times 18. Okay, now I know that when I multiply, I get to 378. But unlike this one, this is not a perfect square, so it's not going to help us. So rather than multiplying, I'm actually going to break it down. So I'm actually going to think, okay, 21 is 3 times 7, right? 18 is 3 times 6, and then I can break that down a little bit further into 3 times 2. Pardon me, Square Bear. And so that's going to be, let's see, now you've got choices here. What I'm going to go ahead and do is I'm going to use my handy dandy blue highlighter, and I'm going to mark 7 is one of the ones, let's see, and I need a 3, and I'm going to mark that I just used that 3. And then I'm going to take this 3, and you don't have to do this, but I'm going to tell you that I'm going to do that 3. I am particularly prone, I just happen to know about myself, to forget or to add additional things in. So I leave out one of them, or I add in an extra one. So a couple ways you could do it. Like I did, I marked them as I wrote them over here. You could try crossing them out. You could try counting. So there's a 7. Yes. There are 3 3s. Yes. There's 1, 2. Good. Or you could just double check this. 7 times 3 times 3 times 3 times 2. And it gives us 378. So I know I've got the right number in there. So one way or another, you just want to make sure you didn't leave any of them out. Okay, so we got everyone assembled in the cabin. Now remember what happens. What's going to happen is anyone who's a twin can go running. And this is Square Bear, so we need 2 to go running. Now 7 doesn't have any twins. 3, there's a bunch of them. 2 doesn't have anybody. So basically just 2 of those 3s are going to go running. And they go running. And then, yum, 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 yum. One of the 3s makes it out. And then everybody else is just stuck inside the cabin. And we will say, hey, I will send help. Right? So one of the 3s gets out, and then everyone else waits. Now, this is really unsatisfying. I gotta say, this problem, who wrote this problem? Seriously, they should be fired. Inside the radical, we've still got 7 times 3 times 2, which I'm pretty sure is 42, but I'm going to double check it. Woohoo! Believe it or not, that is the best form for this answer. And I would agree that most human beings have no idea what that means. A bunch of math teachers do. I could probably figure it out. Most people, I think, would have trouble understanding it. So in another setting, it may be that what you want is to know that the square root of 378 is 19.4422221 and some other numbers. That is an approximation, though. This is the exact actual value. And normally what we're going to do in math is we're going to be the ones that come up with the exact value. We will simplify the exact value. And then we hand that number off to whatever other field is using it so that they can decide how they want to approximate. How do they want to round? It could be that the person who needs this is going to round this as basically 19. It could be that they're going to say, it's close to 19 and a half. That might be what they need. It might be that they say 19.442 is their choice. And our job as the mathematician to give them the exact value, so then they choose how they're going to approximate it. Hopefully that makes sense. Okay, shall we go to the second page? This is very exciting. I know, you guys are like, yes, let's do it. Woohoo, more Square Bear. Square Bear forever. Woo, Square Bear forever. Yay, don't look at the scary things. No, we're not looking at all. And again, you know, you can always bring in additional support creatures. Make sure you've got, you know, make sure you're well rested. Make sure you've got your hydration. Make sure you've got your support crew. And let's get going. You guys ready? We can totally do this. Okay, so I'm going to ask Sharktopus to stand off to the side over here. He's just watching you right there. See? And Square Bear is waiting. There we go. They can have a nice little carnivore conversation. And then we're going to take a look at this. Wow. There's a lot of stuff going on there. I think most people would agree that's a big old bunch of stuff. And as I look, I've got radical 8x cubed y to the 5th times radical 4x squared y cubed. And each of these doesn't simplify. So I should say neither of them simplifies nicely. There's no obvious simplification. I mean, maybe that 4, because I know what the square root of 4 is. That's 2, right? And the x squared, perhaps. But the rest of it's a mess. So what I'm going to choose to do is I'm going to go ahead and combine them and then break them up, if that makes sense. So, pardon me. I'm going to move my support crew to over here. Here we go. They can just, you know, hang out. Oop, you can't see Sharktopus. Sharktopus is right there. There we go, one of his tentacles. Okay, so I'm going to move them over here so I've got lots of space, because remember, your support crew should be there to support you, but not to get in the way. They should be supporting you to take the space you need. So first thing I'm going to do is I'm going to say these are both radicals. They're both the same kind. These are both square roots, so I can combine them. Also because it's multiplication, right? Addition, subtraction, no, this isn't going to work. It's only multiplication. That's going to work like this. And then I'm going to take 8x cubed y to the 5th times 4x squared y cubed. Now, there are a bunch of ways to approach this. What I will probably do is I will probably rewrite these two in a way that's going to be easier to work with. And what does that look like? Well, it looks like this. 8 times 4. I took the 8 and the 4. And again, if you've got a highlighter close by, you can always, you know, underline. There's my constants. And my x's, I'm going to have 2 x factors. Ooh, x factors. I know. That's because math is so cool. And then I can underline my y's. There are 2 y factors. Notice these aren't terms because I'm multiplying. These are factors. But I am allowed to switch the order because we've got something called the commutative property, which says when you're multiplying, you can move stuff around. Okay, so now normally if the square root or the radical weren't there, if it were just like that, ignore that, then I would combine these, right? I'd make them smaller. But again, when we're talking about radicals, I want to see what's actually happening inside. Now at this stage, if you don't use Square Bear, if you have another way of approaching it, go ahead and do that way and come back at the end because we'll get to the same answer. But what I'm going to do is I'm actually going to write the 8 as a 2 times a 4. Now this is interesting. I'm going to stop at the 4 and let me show you why in the next step. Give myself a lot of space. So the 8 is now 2 times 4, and then I've got another 4. See, that way I have twinsies. Could I go down to all 2s? Yes, I could, if you'd rather. But you're also allowed to stop. If you see twinsies, you can stop there. Now 8 cubed times, x cubed times x squared. X, there's the x cubed, x, there's my x squared. Then 5 of the y's, y to the 5th, y. Okay, and then y. Those are my 3 there. Okay, does that make sense? So what I'm doing is I'm basically taking that notation and I'm expanding it. I'm actually writing out all the x's, all the y's. Okay, next step. I'll use pink. Okay, here comes Square Bear. They're all in the cabin. Oh no! The Wi-Fi has gone out. Oh no! And they've got to make a break for it. But Square Bear is going to catch you and eat you, so you got to go in pairs. So the two fours, what do? They run together. Oh, my equals that's a little premature right there. Sorry about that. I got excited, thought I could fit in an equals there. I'm not going to. My arrow needs more space. Okay, so the fours go running. Yum, 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 yum. And 1 4 makes it out. Okay, let's see. These two X's go running. 1 X makes it out. Okay, now you get to choose which two X's. The other X's go running. I'm just going to take those two running. But notice that leaves this X inside. Same thing, I didn't circle it yet, but the 2 also did not run. Okay. You don't have to do all this notation. This is just stuff I made up. I don't know if anyone else in the universe uses this notation. But again, personally, I know my eyes sometimes are not the best at doing math. So to help myself not miss things, I'll circle things. I use a lot of colors, so I don't miss them. So circling helps me remember who hasn't run yet. Okay, let's go into the Y's. Let's see. I've got these two Y's, which are going to run. Yum, 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 yum. Okay. These two Y's are going to run. Yum, yum, yum. Yum, yum, yum. Okay. These two Y's are going to run. Yum, 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 yum. And one comes out. And then these two Y's are going to run. Yum, 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 yum. Oh my goodness. So let's take a look. Let's remember x cubed times x squared, 3x's times 2x's. So I had altogether 5 x's. 2 come out, 1 stays in. With the y's, I had 5 y's and then 3 y's, right? Y to the 5th times y cubed. So altogether I had 8 y's multiplied together. They all went running because they could all pair up, and I ended up with 4 y's coming out. And who's left inside the cabin? Just my 2 and my x. So altogether, I've got 4, 2 x's, x squared, 1, 2, 3, 4, y to the 4th times radical 2x. Woohoo! Kinda, sorta, little bit, maybe. So, what is the pattern that we're going to follow? How do you remember what the steps are? What the steps are, when we're asked to multiply, we're going to bring everybody together into a single square root, radical, cabin, whatever you want to call it. Then we're going to see who's actually in there. And in order to do that, I switched all the factors around. I put the numbers and then the x's and then the y's. Grouped them together with their like factors, and then I expanded them so that I could do the every 2 go running. And again, if you don't do it that way, maybe you want to look at it as x to the 5th and y to the 8th, and that'll help you simplify in another way. There are other ways to do it, believe it or not. Okay, and then once I've brought everyone out who can possibly get out, then I, again, because x times x it's not the best way to write it. It's better to write x squared. And y, hard to read, so we just write y to the 4th. That's the shortcut symbol that we use with the exponents. Okay, shall we do another one? Yay, let's do another one. Oh no, dun dun dun. Now, is this the end of the world? No. Is this a little bit intimidating? Maybe. So let's take a look at what we got. First thing I'm going to do, whenever something is scary, is write really big. That's the rule I learned a long time ago. Write it big so nothing can, sneak away. And then I'm going to take a look at this and go, okay, I've got radical x, or square root of x, and then a parentheses, and then 2 plus radical 3. Now, I'm going to take a moment and cover this up and then think to myself, I remember this format from before. A times the quantity b plus c. This is just the distributive property, right? So we do a times b and a times c, right? A goes to visit b, a goes to visit c. A times b plus a times c. Now, is it going to change just because it's horrible? No. It's exactly the same situation. And it's not really that horrible. It just looks a little bit different, maybe. So let's take a look. I'm going to draw the arrows. You don't have to. And I'm going to say, okay. So radical x is going to go visit 2. So I've got radical x times 2. Now, I'm going to do a times in the middle. You don't technically need it, but I think that if the 2 gets too close, sometimes things can get sucked into square roots if you're not careful. So I always try to be very clear with my spacing. Okay, next one. Radical x multiplied times radical 3. So far, so good? Okay. So I used the distributive property. I eliminated the parentheses. Yay! Partially done. Is this the best way we can write it? No. There are some things we could do to make this a little easier to write it. First thing is, the rule is if you've got a whole number or a variable, put it in front of the radical. What does that mean? I'm going to write it as 2 radical x plus, and then over here, if you've got 2 matching radicals, which we do, they're both radicals, they're both square roots, I'm going to go ahead and write them together. Now, should I write it as x times 3? Technically, you could, but if you're going to make it look really nice, the usual rule is that the constant goes first in front of the variable. It's just the convention. It's the way we do it. Woohoo! Yay! Okay, that's page 2. This is exciting. You guys are doing great. Woohoo! You ready? This is very exciting. Let's look at number 5. Dun, dun, dun! Okay. Okay, so I agree. Number 5. Number 5, remember you can always take a break. You can always pause. You can always ignore what's written down here. Don't worry about that. Okay, so what do we got up here? I've got 2 plus radical 3 in parentheses, and then 3 minus radical x in parentheses. And so I'm going to pull out that piece of paper, and I'm going to say, draw a line. If I have a plus b in one parenthesis, set of parentheses, and I have c minus d in another one, how do I multiply if I have that format? It's not just the distributive property. What do I use? You got it. You got it. We're going to have to use FOIL. This is if you've got 2 terms over here and 2 terms over here, we're going to use FOIL. Now, could you use the other method to multiply 2 polynomials? Abso-stinkin-lutely. So use any of those methods you like. I'm going to go ahead and use FOIL because that's in fact what I intended for this one. So this problem will be a FOIL problem. First, outer, inner, last. So first thing, I'm going to rewrite this slightly larger so I know what's happening. I think my hand just likes to know what the problem is. Okay, you guys ready? We can totally do this. Deep breaths. You got this. Okay, so first, my first is going to be the 2 and the 3. 2 times 3. Outer, it's going to be these 2, right? So this will be, now it depends on your perspective. You could do plus and then the multiplication, but notice that on my outer, I've got positive 2 and the opposite of radical x. So that's going to give me a minus right there. Okay. I'm going to point out that this right here came from this right there. Okay. Okay. I, that's the inner, that's going to be these. They're both positive, so radical 3 times 3. So far, so good. And last, it's going to be positive radical 3 times the opposite of radical x. So it's going to be another minus radical 3 times radical x. Again, I'll circle this to remind you that this minus comes right from there. Okay, what do you guys think? Now, I wish we were in class, because if we were in class right now, I could say, okay, what do you think? Should we stop here and we could discuss it? Unfortunately, you know, when I'm doing this, I'm talking to a computer. I'm actually talking to my rabbit. Believe it or not, my rabbit is right underneath the desk, snuggling my foot. He loves videos. He thinks I'm talking to him. He is probably the one rabbit in the whole universe that knows the most about algebra at this point. This rabbit knows FOIL. Okay, so, but he's not very good at asking questions. So I'll remind you, please ask me lots of questions. Totally reasonable to say, hey, in that video you made, I didn't understand number 5. What the heck happened? Why were there minuses everywhere? You know, definitely ask. So, but what I'm going to do at this point is, since I don't know if you have any questions, I'll just continue on to the next step. The next step is to clean up each term. Now, a lot of people are like, what am I going to do? It's so much. It isn't so much. Each step is one step. So 2 times 3 is, you got it, 6. That's all that step was. I don't try to match anything with anything. I don't try to combine. I'm just multiplying this out. Next term, minus 2 radical x. Well, there's nothing to simplify about this. So that's just going to get written as minus 2 radical x. Okay. Now, next one, radical 3 times 3. Now, there's nothing I can do because this is a radical and this is a whole number. I can't smush them together, but I can write them in a better order. Remember, whole numbers should go out in front. So what does that mean? I should have 3 radical 3. Okay. And then these two, now this is interesting. I've got minus and then radical 3 radical x. Those are both radicals, so I can combine them like this. And that's it. That's how it's written. That's the final answer, believe it or not. I know it's kind of unsatisfying, isn't it? It's just kind of not very pleasant. And if you're and I shouldn't say that, because some people are looking at this going, wow, that's so cool, or I'm so glad I understand it, and that is wonderful. But I'm going to say that looking at this, I find it somewhat unsatisfying. It's almost like it's missing something. But if you want to think even harder about this, an interesting thing to think about is, could you imagine how to untangle this so you could get back to this? That's kind of interesting to think about. The 6 kind of suggests the 2 and the 3. I've got there's a 2 there, there's a 3 there, there's a radical x, there's a radical 3. You could probably do it. We could all work together to go the other way to actually factor this. So that's an interesting thing to consider. Okay, are you guys ready for the last one? Dun, dun, dun! Now, this one, in my mind, I think I want to finish up with this one because I think this one is so cool. Are you guys ready for the one that I think is so cool? We'll see if you guys think it's so cool too, compared to number 5. Number 5 is great. Number 5 is correct. But number 6 is so satisfying. I just love it. So I've got 3 plus radical x times 3 minus radical x. Okay, already. Bit of a nightmare, right? Radicals, all sorts of things running around. Again, 2 terms, multiplied together. This is FOIL. Okay, first, First is going to be 3 times 3. Uh-oh, I'm going to run out of room. I got to stop writing so big. Okay, outer. There's a 3, and there's the opposite of radical x. Just like up here. That minus that was right here that just kind of went and infected everything, the minus here is going to go through. So here, 3 times the opposite of radical x is the opposite of 3 radical x. I, inner, that's radical x times 3, and they're both positive. And then L, last. I've totally run out of room. But for the last, it's radical x times the opposite of radical x. So it's the opposite of radical x times radical x. Oh my goodness, that's so smushy. So let me write it nicely over here. Okay, 3 times 3. You know what? I'm just going to copy the whole thing because it is kind of hard to read, and then we'll simplify. Okay, so let's simplify. 3 times 3 is 9. You got it. Okay, nothing to do with 3 radical x. It's simplified. Now, when the radical comes before the whole number, put the whole number in front. Okay, so again, each step does not require you to do the whole problem. Each step is just look here, then look here. Look here, simplify. Simplify. Interesting. What's going on here? I've got 2 radicals. I can stick them together, right? X times x inside the radical. And then I notice something wonderful, amazing. Take a look at what happens right there. Minus 3 radical x plus 3 radical x, they're opposites. I'm taking it away. I'm adding it back in. It means they cancel. They cancel completely. Cannot draw that C to save my soul. So I've got a 9, and I've got 0, and I've got minus radical, what is that, x squared? But wait a minute, what is x squared? What's the square root of x squared? What's radical of x times x? You're right. So the whole thing's going to be 9 minus x. Whoa! So what happened? I multiplied 2 seemingly complicated, right? These are binomials. These are 2-term, not really binomials, they're radicals, but they're 2-term expressions. And you've got 3 plus radical x and 3 minus radical x. So we've got that a plus b, a minus b situation. And when that happens, the middle cancels out, and we get the 3 squared is 9, and the radical x squared is x. So this is actually an example of a plus b, a minus b, and then you get a squared minus b squared. Now, did you have to be able to see that? No, that's not required. The benefit of FOIL is that we can always do things the long way. If you don't see the shortcut, or if you're not sure of the shortcut, you can always take the long way around. There's always a longer way to go in math. There's always a longer way you can do it. And that way you just basically reinvent the wheel, and that's fine. And then as you're going through, you see all these amazing things happen. But what I find so fascinating is that 9 minus x has multitudes within it, right? It's got all that happening inside, and you would never have guessed. So it's pretty cool. Okay, so there is a note down here. Radical expressions that follow the pattern a plus b, a minus b. So in other words, they match except for one has a plus and one has a minus, are called conjugates. And conjugates just means, that comes from Latin and possibly Greek, it just means goes together. They're the ones that go together. So it's kind of cool that these are conjugates, and we will use these in the future. They will be really helpful. Why are they helpful? Well, if I have a square root or a radical, if I bring in his best friend and get them together, I can eliminate the square root, which is going to be really helpful. So, you guys are awesome. Square Bear was awesome. Thank you, Square Bear. Thank you, Sharktopus, for being here, offering support. Thank you, Square Bear. And, you guys are amazing and incredible. And I hope you have an amazing, incredible day. I hope you get out and get some fresh air, maybe even some sunshine if there is any when you're watching this. And I hope you get some vegetables and some good sleep and some good exercise and some good quiet time, and that you recognize how amazing and incredible you are. And when you've done that, then, no one can stop you. You're amazing. Woohoo. Math on.